This is Algebra 2 with trig. This is Chapter 3. So we're going to look at a system of equations. Two equations with x and y. So that you have ax plus by equals c. That would be one equation. Dx plus ey equals f. You have your first equation, and you have your second equation. Now when we're doing these problems, we'll have numbers in for a and b, and c, d, e, and f. The part that's going to be similar will be that they will both have an x and a y in the equation. The solution of this system is an ordered pair. Ordered pair, xy. It satisfies the equation. It's consistent. A solution is considered consistent if it has at least one solution. It's inconsistent if it has no solutions. So if your two graphs are going to cross at one spot, or at least one spot, then that can be considered consistent. If they do not cross at all, then there's no solution. Your system can be considered independent if it is consistent. That means it has at least one solution, and it ends up being exactly one. You're dependent if it's a consistent and you have an infinitely many solutions. So here, if you have two lines that cross, it's going to have exactly one solution. Infinitely many would be if your two lines were parallel. Well, that would be that would be inconsistent. So infinitely many is going to be if the lines are exactly the same as each other. That way all the solutions are exactly the same. We're going to solve this system geographically. Graph the system and estimate the solution. So there's a couple different ways we could graph this. Typically what we like to do is convert it over to y equals mx plus b. You could solve for the zeros and connect the dots. So I subtracted the 4x over, I divided by 2. Now I'm going to have a y-intercept up at 2 and a slope of negative 2. So then we'll connect the dots together. The equation is y equals negative 2x plus 2. We'll take the second equation, subtract the 2x over, and we're going to divide by 3. two negatives will make a positive slope. And we know that 10/3 is going to go in there 3 1/3 times. Then we're going to have a slope of 2/3. Connect your dots together. Our equation here is y equals 2/3 x minus 10/3. So it appears that our solution of 2 comma negative 2 is a solution of our system of equations. That's a spot where if you plug in 2 negative 2, both equations would be true. Let's test that out. So we're going to plug in our 4, our x value is a 2, our y value is a negative 2, (8) and negative 4 give us 4. So 2 negative 2 is a solution of the red graph. That means that 2 negative 2 lies on the red graph. So plugging in 2 negative 2 into the second equation, and it made this a true statement also, saying that 2 negative 2 is a solution for the blue graph. Alright, so now we look up here, we know this would be considered a consistent system because it has at least one, and it ends up being independent because it has exactly one. On the second page of our notes, we see some graphs that are representing the different types of solutions we can have. Lines that intersect at one point are consistent and independent. If we have our lines that coincide, that means there are two lines that are on top of each other, and they are called consistent and dependent. If your lines are parallel, then it's considered inconsistent. That's the only one that's inconsistent. So here we're going to graph these two. We'll add the 2x to the other side. Start up at 4. Do our slope of 2. So we're going up 2 over 1, up 2 over 1, up 2 over 1. Our second equation divide by negative 2, We're up here at 4 with a slope of 2. So our second graph coincides with the first graph. So we'd like to write the equations. We have our y equals 2x plus 4 and y equals 2x plus 4. The graphs of the equations are consistent because they are not parallel. They don't have the same slope with different y-intercepts. Each point on the line is a solution, and the system has infinitely many solutions. Therefore, it is considered dependent. Is it going to be consistent and independent, meaning it crosses at one spot? Consistent and dependent, every spot's the same? Or is it inconsistent where they're parallel? This will cross once. This is the same line. And this is parallel. Take the equations. Two divided by 4 is 1/2. 8 divided by 4 is 2. Our slope is up 1 over 2. Down 1, backwards 2. Our second equation. A y-intercept of -1, up 1 over 2, up 1 over 2. Sounds familiar. So we have y equals 1/2 x minus 1, and we have y equals 1/2 x plus 2. The two graphs of the equations are two parallel lines. Therefore, the system is inconsistent. On the third page, we're looking to see if they are consistent and independent, consistent and dependent, or inconsistent. So that's our first equation. Divide by 3. A -3 is going to turn that positive. Divide by a negative. So at -1/3, we're going to go up 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. So we have y equals 4/3 x minus 1/3. We have y equals negative x plus 2. The solution is 1, comma 1. It's consistent because it crosses at least once, and it's independent because it only crosses exactly once.